Mount Etna, Europe's tallest and most active volcano, has just cracked open along its side, literally split itself wide like it's done pretending to be stable, and scientists are freaking out harder than a Hollywood publicist during a live mic scandal. This isn't some little puff of ash. This is a colossal flank fracture, a 100-foot wide gash ripping through the southeastern side of the volcano. And if you're thinking, that sounds bad, congratulations, your instincts are right. Because this isn't just a crack. It's a full-blown geological red flag. Etna's not just acting up, she's reenacting one of the deadliest plays in Mediterranean history.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
You see, this exact spot, this fracture zone, it's sitting right along the same prehistoric failure plain that collapsed 7,200 years ago. That collapse didn't just send rocks flying. It triggered a tsunami so massive, it wiped out coastlines, reshaped ancient geography, and basically screamed run to every creature within range. And now, that ancient failure pattern, it's back. Identical geometry, identical slope, identical seismic behavior. It's like Mother Nature hit copy-paste and forgot to warn us. Let's be very clear, this is not a drill. The southeastern flank of Etna is now in motion, not metaphorically, literally sliding. Sensors are picking up ground displacement that's no longer measured in harmless centimeters but in meters. Whole chunks of the mountain are shifting like tectonic Jenga blocks, and no one knows how long we have before gravity wins and it all comes crashing down. But before we get to how bad this could get, spoiler, it's real bad. Let's zoom out for a second. Etna has always been a diva. She's erupted more than 60 times in the last 100 years. She regularly spits lava, chokes the sky with ash, and terrifies airlines into rerouting flights. That's just Tuesday for her. Locals are used to her drama. She's the unpredictable, fiery neighbor you learn to live with. But this isn't drama. This is decay. Because when a volcano's flank fractures, it's not the same as an eruption. It's not about fire, it's about structure. This is the mountain's foundation shifting. And when the side of a volcano begins to fall away, it can trigger what's called a sector collapse. That's when a massive part of the volcano detaches and barrels downslope, often into the sea at terrifying speed. Now, here's the kicker. When something that big crashes into the ocean, the water doesn't just sit there politely. It reacts violently. Displacement of that magnitude sends tsunami waves rocketing across the Mediterranean. And thanks to modern modeling based on ancient tsunami deposits, scientists now believe those waves could reach up to 25 meters high. That's 8 stories of water, moving at jet speed, with barely minutes of warning. From Sicily to Malta, from Calabria to Tunisia, millions of people live within range of a wave that could hit with almost no notice. You won't get time to pack a bag. You'll be lucky if you get time to run. And what makes this nightmare even worse, the collapse wouldn't be quiet. It could set off a chain reaction of volcanic chaos. See, Etna isn't just some cone of rock with a bit of lava in the middle. She's a multi-chambered, high-pressure beast. A magma system so complex it's basically a plumbing diagram drawn by a madman. Scientists have mapped deep magma reservoirs, fractured conduits, and volatile gas pockets all laced together like a boiling bomb beneath the crust. When the flank collapses, that plumbing gets exposed. That pressure gets released. And if the collapse destabilizes the magma chambers, we're not just talking tsunami. We're talking eruption. Explosive. Violent. Maybe even caldera forming. Think Krakatoa meets a regional shipping crisis. But let's talk about the science, because it's not just fear, it's data. Right now, drones are flying above the fracture zone, collecting thermal images that show increased heat and gas emissions. Satellites are tracking deformation in real-time, meters of tilt, ground lift, and shearing movements across the fracture line. LIDAR scans show displacement accelerating each day. Seismic stations have recorded a sharp uptick in tremors, those microquakes that act like the volcano's stress tweets. And gas analysis, it's showing spikes in carbon dioxide and hydrogen sulfide, both signs of pressure cooking underground. Then there's the lava. Recent eruptions have spewed out unusual compositions, lava so chemically strange that even top European labs are scratching their heads. Some samples don't match any known eruption in the volcano's documented history. That's not interesting. That's what's brewing under there is new, and we don't know what it can do. And the gouge layers. Oh, you better believe we're talking about gouge layers. Deep in the volcano's structure are zones of crushed, Unstable rocks so soft and slick they might as well be made of grease. These are natural slip zones, and Etna's southeastern flank is full of them.
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
These geological weak spots are basically lubricating the entire flank, helping it slide like a knife through warm butter. In other words, the mountain wants to fall. It's ready. It's just waiting for a trigger. And here's the horrifying part. That trigger could be anything. A strong enough earthquake, a major eruption, a flood of rain seeping into the fracture, even just the slow buildup of stress over time. One nudge in the wrong direction, and it's over. So what are authorities doing about this? Well, they're trying. Emergency services are coordinating with geologists to monitor the fracture 24/7. There are contingency plans, evacuation protocols, and local officials claim they're ready. But let's be real, those plans were designed for eruptions, not for a mountain falling into the sea. Evacuation drills already showed delays, road bottlenecks, and communications breakdowns. The systems aren't built for a wave arriving in under 10 minutes. And with how rapidly the situation is changing, every hour without a solid, region-wide plan is a gamble. Behind closed doors, leaked memos are revealing tension between agencies. Some scientists are begging for public alerts, mass evacuations, early closures of coastal areas. Politicians, on the other hand, are hesitant. Too many tourists. Too much economic risk. Not enough time. But that's the thing about natural disasters, they don't wait for the next election cycle. And as this slow-motion collapse unfolds, the gap between what we know and what's being done is widening dangerously. So if you're wondering, why aren't more people panicking? The answer is simple. Most don't realize how close we are to the edge. Unless you're reading geological bulletins for fun, you're not seeing the full picture. And that's how disasters happen in silence, until they don't. Now here's where you come in. If you're watching this and thinking, wow, this sounds like a disaster movie, congratulations. It could be. Except this one's live. No CGI. No rewrites. Just a volcano, a fracture, and a ticking clock. So what would you do if you lived near Etna right now? Would you stay? Pack your bags. Start sleeping with shoes on. Let us know in the comments, because this kind of story demands input from everyone. And don't forget to subscribe, because we'll be tracking every development from satellite flashes to seismic warnings. When the next crack opens or the first wave hits, you'll want to know before it's trending. Until then, stay alert, stay skeptical, and if a mountain starts whispering, listen closely, because sometimes nature doesn't give you a second warning. And the scariest part, Mount Etna doesn't need to erupt to destroy everything in its path. She just needs to let go. See, when people think volcano disaster, they imagine the classic eruption, lava shooting into the sky, ash clouds darkening the sun, villagers running dramatically downhill. But this is worse in a way. It's silent collapse. A slow, creeping fracture that no one can feel until it breaks. And when it breaks, it's not going to give anyone time to tweet about it. Right now, that southeastern flank, already the most unstable part of Etna, is behaving like a ticking geological time bomb. Every hour, scientists record new data, the tilt increasing, the displacement growing, seismic tremors shifting locations. It's like the mountain is communicating, and the message is getting clearer by the minute. I am not okay. But there's a weird, unsettling quiet in the way the general public is reacting, mostly because they're not. You'd think news like this would spark a media frenzy. Tsunami risk, regional catastrophe, ancient collapse reactivated. It should be headline material. But for most people, it's background noise. Another vague volcano doing something story in a world already drowning in disasters. And that's dangerous. Because unlike hurricanes, there's no multi-day warning for a flank collapse. You can't track it on a map as it approaches. You don't get a countdown with a helpful cone of uncertainty. When this goes, if it goes, it just happens. And depending on the size of the collapse, the tsunami it triggers could be visible on the horizon 5 minutes after impact. Just imagine that for a second. You're standing on a sunny beach in Catania, maybe wondering what all the seismic talk is about, and then suddenly, the water starts retreating. Boats tip oddly in the harbor, and then over the sea you see it. A wall of water. You run. Everyone runs. But with what time? And what if it's nighttime? What if the collapse happens at 2 a.m., while people are sleeping? Who gets the alert? Who wakes up? Who makes it out? That's the kind of question keeping volcanologists and emergency planners up at night. And it should probably be keeping the rest of us up too. Because this isn't an if, it's a when. Every signal coming from Etna points in the same direction. She's shifting, she's groaning, and her side is coming loose. And this isn't some rogue theory. This is grounded in history. Geological surveys have shown that the ancient collapse 7,200 years ago followed the exact same fault line now reactivating beneath the southeastern flank. That's not coincidence. That's repetition. Nature remembers. The last time this happened, the tsunami triggered left behind sediment deposits miles inland, layers of ocean sand and debris in places that are now thriving towns and coastal cities. And what's worse, back then, there weren't millions of people living near the coast. There weren't megaports, cruise ships, airports, chemical plants sitting at sea level. We've built a fragile modern world on top of ancient scars. And now the scar is reopening. Let's talk infrastructure, because this is the part no one wants to think about. If a 25-meter wave hits the Mediterranean coast, what happens to the power grid? What happens to water supplies? Transportation? Hospitals? Dozens of coastal towns rely on narrow roads and outdated emergency routes. Some areas have one access road in and out. 1. You can feel the tension bubbling behind every government press release. The language is carefully manicured. Increased monitoring, routine activity, no cause for alarm. But the scientists, they're not using those words. Privately, they're talking collapse scenarios, worst-case modeling, mass displacement. They're not asking if Etna will slide. They're asking how much of it will go, and how fast. And it's not just the physical threat. It's what happens afterward. A massive flank collapse and tsunami would devastate the region's economy. Ports would be destroyed. Trade routes shut down. Agriculture wiped out. Airports flooded. It would take years to rebuild, and that's assuming there's anything left to rebuild at all. And don't even get started on global headlines. Because the moment Etna falls into the Ionian Sea, the footage, satellite imagery, drone captures, smartphone videos will circle the planet in seconds. And suddenly, everyone will care. Too late. That's the cruel rhythm of disasters. The world only watches after the damage is done. But right now, we're still in the prologue. The fracture is widening. The sensors are screaming. The data is coming in, and it's all saying the same thing. Prepare now or pay later. So if you're anywhere near southern Italy, Sicily, or Malta, maybe it's time to ask some hard questions. Do you know your evacuation route? Do you have a go bag? Do your friends and family understand what's happening? Would you even know if the mountain started to fall apart? Because at this point, Etna is on borrowed time. And she's not the kind of volcano that lets go quietly. Let's not sugarcoat it. If the worst-case scenario plays out, it will be one of the most significant natural disasters in modern European history. And what's surreal is that we're watching it line up right now in real time. The crack is open. The slope is moving. The gas is rising. The magma is shifting. All that's left is the final trigger. So here's your reminder. The Earth has a memory. And sometimes, she likes to repeat herself. If you're still with us, sound off in the comments. Do you think Etna's bluffing? Or is this fracture the beginning of something massive? What would you do if you had 10 minutes to get to higher ground? And would your local emergency system even give you that time? You're not going to get a polite 72-hour heads up from nature. You'll get a tremor. Maybe a deep rumble. Maybe not even that. And then, wham! A 1,000-year-old landslide in real time. Let's pause and talk about what that would look like. Picture it. A section of Mount Etna, bigger than several city blocks, detaches from the rest of the volcano and begins to slide downward, slow at first, then fast. It gains speed, breaks apart, pulverizes forests and trails, and slams into the Ionian Sea with a force equivalent to a small nuclear blast. Not exaggerating. That much rock and debris moving at that speed. It's going to move the ocean. The splash isn't a splash. It's a shockwave. The water doesn't ripple, it rises. And that's where the real terror begins, the tsunami. Simulations suggest waves reaching 20 to 25 meters high. Yes, that's basically an 8-story building of ocean, folding itself up and hurtling toward the shore. Not just Sicily, but coastal towns across southern Italy, Malta, and potentially as far as North Africa. These waves don't politely knock. They smash. They sweep through ports, over sea walls, and into towns with all the delicacy of a freight train. Boats end up on rooftops. Cars vanish like toys. Concrete cracks. History drowns. And it all happens so fast. That's the part people struggle to grasp. The speed. There's no 5-minute grace period. By the time you see the water rising, it's already too late to run. And let's be brutally honest, most of these coastal cities, they're not ready. Evacuation routes are poorly marked. Siren systems are outdated or non-existent. Emergency response teams are underfunded, underprepared, and overstretched. Local officials are still trying to not cause panic. Tourists aren't being told the full scope of the threat. It's like a horror movie where no one's read the script except the volcano. And the volcano is getting impatient. Back to the fracture, it's not just any crack. It's following a very specific path. Geologists have matched its location, depth, and tilt to a prehistoric failure event that occurred over 7,000 years ago. And if you're thinking, well, that was forever ago, yeah, except the Earth doesn't forget. And when the exact same pattern starts forming again, that's not coincidence, that's a sequel. And sequels tend to be bigger. The ancient collapse triggered a tsunami that scientists have traced through layers of sand, shells, and ocean debris embedded inland. We're talking about sediment pushed miles from the shoreline. Which means, yes, that ancient wave flattened everything in its path. And now the Earth is pulling out the old blueprint and hitting print again. And we're just standing here, waiting to see if the ink runs. Now, let's not forget Etna's inner workings. Because while we're all staring at the fracture like it's the big problem, what's underneath might be even worse. Etna is one of the most volcanically complex systems in the world. It's got multiple magma chambers stacked like a volcanic layer cake. They feed into one another, with deep reservoirs connected by fractured, unpredictable conduits. The result? Pressure building at multiple depths, gas emissions that spike without warning, and a history of surprise eruptions. It's like trying to monitor a ticking bomb with 1,000 internal clocks all set to different times. And those lava samples scientists have been analyzing lately. They're weird. We're talking about rocks that don't match previous eruptions. Chemical signatures that suggest new magma sources. It's like Etna is opening a new chapter in its evolution only instead of a quiet geological shift. This chapter might end with a landslide and a regional flood. And while scientists are in full detective mode, piecing together every gas reading and seismic blip, politicians are, let's say, playing it safe. Because here's the reality. Calling for a mass evacuation when the volcano hasn't technically erupted yet. That's a political gamble. Shutting down entire coastal economies based on potential collapse scenarios. Career-ending stuff. So the warnings get filtered. The language gets softened. The urgency gets lost in translation. Meanwhile, Etna keeps shifting. Ground sensors have recorded daily movement that exceeds normal volcanic activity by orders of magnitude. And this isn't just settling. This is mobilizing. The mountain is aligning its stress, its pressure, and its geology for a break. And what's terrifying is how normal it still looks. You can stand on that slope right now and not feel a thing. The fracture might be hidden by trees or buried under the soil. The ground may feel solid, but the instruments say otherwise. The earth is flexing beneath your feet. It's moving in silence. And that silence, that's the warning. Thanks so much for watching. If you made it all the way to the end, you're officially part of the small percentage of people who don't just click away, and that means a lot. Before you go, I'd love to hear from you. Drop a comment below and tell me your thoughts, your ideas, or even what you'd like to see next. I read every single one of them, and your feedback genuinely shapes the direction of this channel. If you enjoyed the video, tap that like button. It tells YouTube this content is worth sharing. And if you haven't already, hit subscribe and turn on notifications so you don't miss the next upload. We've got more exciting videos coming, and trust me, you'll want to be here for them. This channel is just getting started, and your support helps it grow faster than you realize. Thank you again for spending a part of your day here with me. Stay curious, stay motivated, and as always, take care of yourself. Until next time, I'll see you in the next video.